Hello everyone. In this project we're gonna look how we can encode vending machine with Vhdl. First of all, we are gonna examine our code, then we are going to examine our test bench, then we are gonna look our uh, simulation. At the end of the video we are going to look our synthesis schematic. First of all, uh, we are going to examine our code. Uh, at the top of the code, of course, we need to add our libraries. In entity port, we examine our circuit's name, then we write port, we define inputs and outputs because it's a finite state machine. We have to use clock and reset inputs. We have money input, money input and money input. At money input, we understand there is a money input case on our vending machine. In money input shows that how much money we add our vending machine. Product given out is a signal or output that shows our product is given, and reminder output shows us vending machine gave the customer the reminder. Then we write end entity and we continue with architecture. We write arc of vending machine is this part is important. In this part we have to indicate our states type. First of all, we need to write type keyword, then we give a name. I gave state type is. Here we write our all states. We have idle state, money inflow state, product given state, and remainder state. Then we write our state signal. Its type is state type. Then we have three signal. Our first signal is money inside. It shows how much money is placed on our vending machine. We write std logic vector 4 down to 0. This shows our signal has 5 bits. And second signal price. This is the price of our products, and all of them are 10 Turkish liras. Of course, it's 5 bits because I want to give both of them same bits. And our last signal, missing money, it's 1 bit. If customer's money is not enough for the products, this signal will work. So let's start begin. Here we write our price, which is 10 Turkish liras. Then we go on with process. Process is depend on clock and reset. So begin. If our reset input is 1, then state will be going to idle. Idle is our first state. Everything will be zero on the state. Then we have to make our all outputs zero. Money inside output will be zero if we have if our signal have more than 1 bit. We need to write others to zero. Then missing money, product given out, reminder out is zero. Because they are 1 bits, we can directly write 0. Then else if rising age clock, then this means we will work with our clock's rising age. It depends on our rising age. Case state is when idle. Idle is our first state, so every output will be zero. The only difference with reset and idle is at reset we write state idle, but in idle we write if else and if. We decide our next state with this case. If money input is equal to 1, then state money inflow. Money inside will be equal to money inside and money. Money is the money that we add to vending machine. Money inside is equal to all money inside of the vending machine. Else state idle, which is else is money input is equal to 0. Then at money inflow state, if money input is equal to when, if money input continue, money inside is equal to money inside plus money, then state will be again money inflow. Else our money input is 0. It has a if it has if of its inside. If money inside is equal or bigger to price, then state product given. Money inside will be equal to money inside minus price. Price, which is 10 Turkish liras. And product given output will be 1 because our product is given. Else, if our money, if inside of the money is smaller than 10, state will be reminder missing money 1 because customer has no money to buy the product. Of course, we write our end ifs. Then we are going to write our another case product given. If our product given, state will be reminder at all possibilities. There is no if. Reminder output will be 1. Product given output will be 0. Then our reminder case, product given output will be 0. Missing money will be 0. It has if money inside is not equal to 0, then money inside is equal to money inside minus 1. Reminder output 1, state reminder. It shows that still there is money inside of the vending machine, so we have to give this money to customer. Else, which means money inside is equal to 0. State will be idle and reminder output will be 0. And if whenever is very important. When we write whenever, we just need to copy resets values and paste it to whenethers. If none of these cases work, our whenethers case will work. And end case, end process, and architecture. We finish all of this, and our code is completed. So next step, we need to write test bench. We add our libraries, and we write our empty entity. Then architecture section, we have to write component. Writing component is very easy. We just need to go back to our code and copy entity case and paste it to component, paste it here and change entity with component. Then we have to define signals. Clock, reset, money input, money, product given output, reminder output, which are placed on our components, inputs and outputs. The circuits that contains clock, we have to write clock process and reset process. When writing clock process, we write constant keyword, then clock period, and we gave it a period. Time is equal to 20 nanoseconds. Then we write begin clock process, begin. Clock is 0, and we wait for clock period divided by 2, and clock period is equal to 1. Then we wait for clock period divided by 2, so half of clock period will be 0, half of clock period will be 1. End process. Then we write units under test, vending machine, port map. We assign clock to clock, reset to reset, money input to money input, money to money, product given output to product given output, reminder output to reminder output. Then we write our process. At the top of the process, we write resets situations. Reset is equal to 1. Then our inputs that are money input and money will be 0. Then we wait for 100 nanoseconds. After that, reset will be 0, and we will wait for clock period multiplied by 2. These are up to you. I gave 100 nanoseconds and clock period multiplied by 2, but you can give whatever you want. The only important thing is your code can work with these values. Then we pass to we are going to with our last situation, giving possibilities. We have 4 possibility. First possibility, money input is equal to 1. Money is equal to 1 Turkish liras. Wait for clock period. Money is equal to 5 Turkish liras. Wait for clock period. Money is equal to 10 Turkish liras. Then again we wait for clock period and money input will be equal to 0. Then we wait for clock period multiplied by 15 because we don't want to complicated simulation. So we write clock period multiplied by 15. It will be clear to see when we run our simulation. 1 Turkish liras plus 5 Turkish liras plus 10 Turkish liras will be equal to 16 Turkish liras, and it's equal to it's enough to buy our product, which is 10 Turkish liras. This is first case, first possibility. Then our second possibility, 1 Turkish liras, 1 Turkish liras, 5 Turkish liras, which is 7 Turkish liras, and it is not enough to buy the product, so it will be give missing money signal. And third possibility, 5 Turkish liras, 1 Turkish liras, 1 Turkish liras, 5 Turkish liras. We add 4 times money, and 5 plus 1 plus 1 plus 5 is equal to 20, and it's enough to buy the product. And last possibility, we have 10 Turkish liras and 5 Turkish liras. They are equal to 15 Turkish liras, and it's again enough to buy the product. We have to put wait because this is empty process. Then we have to finish process and architecture. This is our third step. Simulate it. To see it better, I'm gonna make it bigger. Here, money input is equal to 1. The next rising age, our state will be changed, and money inflow state is now we are at money inflow state. Money that we will add to vending machine is 1 Turkish liras. We add it at rising age. Total money is money inside, 1 Turkish liras. Then other rising age, we have 5 Turkish liras, and money inside is 6 Turkish liras. The next rising age, we have 10 Turkish liras, and money inside is 16 Turkish liras. So here product given out signal is worked, so our state is product given. When we give the product, our money is our money inside is equal to money inside minus 10 Turkish liras, because our product's price is 10 Turkish liras. Then we continue with remainder state. Here remainder signal is 1, so our state is remainder at rising age. We have 6 Turkish liras, but it will be decrease 1 Turkish liras at every rising age. 5 Turkish liras, 4 Turkish liras, 3 Turkish liras, 2 Turkish liras, 1 Turkish liras, and 0. Here our reminder out signal is 0, so our state is idle. Idle is our starting stage. It will continue as an idle until our money inflow state. Here money input is 1. The next rising age, our money inflow is our state is money inflow at next rising age. 1 Turkish liras, 2 Turkish liras, 7 Turkish liras. 1 plus 1 plus 5 is equal to 7, because our money is not enough to buy the product. It give missing money signal, then it will give our money one by one. 7 Turkish liras, 6, 5, 4, 3, 2, 1, 0. Then again we back to start idle. Again money input is 1, money input signal is 1, money inflow, we are at money inflow state, 5 Turkish liras, 6, 7, 12. We add 5, 1, 1, 5 in order. Then we gave product, money inside is 2 Turkish liras, at reminder state 2, 1, 0. We gave the money one by one. Our last state, or last case, last possibility, customer gives 10 liras, then 5 liras, money inside is 15 Turkish liras, product given, so money inside is 5 Turkish liras. In reminder state, it gives money one by one. At the end there is no money inside of the vending machine. We simulated and we have just one step is schematic. This is the schematic of our code. As you can see, it's very complicated if we design it in physical, but we can write this complicated circuit at Vhdl very easily. So it's very useful method to use Vhdl while encoding this digital devices. Thanks for watching and listening to me. Goodbye.